Hi, this is my presentation for ECEN 160, the final project. This is the layout for my final project. It loosely mirrors the block diagram we were given in the instructions. This was actually fairly simple to do because of the instructions and the step-by-step instructions that we were given. Once I blocked things out, I went ahead and switched over and created my truth tables and populated the opcodes, which I would then use to program the instruction decoder. And that instruction decoder mirrors what I put into the truth table in my opcodes. This was one of the first challenges I faced after creating most of the subcircuits, is just making sure that everything lined up correctly. And this was, I think, in retrospect, quite a good idea, was to stub out most of the circuits inside of the main block diagram and then go back and populate the instruction decoder's truth table, because at this point in time I could easily see how things were going to hook up. My program PROM right now is programmed to show the hardware subtract. I've gone ahead and added a reset button to make it easy for me to go back in time and set things back to the beginning. And we can see it loads up the registers appropriately. It'll switch out and do this hardware subtract and store that in the accumulators in the ALU. It will then go ahead and populate that value into the register, as well as the prefix for ASCII codes, the ASCII number, and then it will dump it out to the screen. And there's our value of 4 minus 3, which is, thank heavens, 1. So the computer's not lying to us. The circuit's implemented as a bunch of subcircuits. Instead of taking the ALU and modifying it to add the hardware subtract, I went ahead and just added a new subcircuit that utilized the existing ALU to make it very transparent to me how things would all fit together. Plus, it made it easier to do the routing of the wiring and everything else. The hardware subtract mirrors the software subtract. It was quite straightforward. It's first an XOR to negate, and then we add 1 to give ourselves a negative 2's complement of the original number. Now, originally I had this set up on the wrong input, and I had to go back and fix that. I'm glad the emulator was there for me to lean on, otherwise I would have had to submit this as is without knowing that I didn't have it quite right. So I was grateful that I could run this through the emulator and see which register was hooking up to which in the order of operations. If we go back to the main circuit, we can take a look at our register file. The two-word register file is built on our existing register that we had built for the previous lab. That's our 4-bit register, which is an aggregation, of course, of the 1-bit registers. The same thing is true of the original ALU. This is essentially unmodified. The only thing I had to change was which went where, which operation went where, in regard to the select inputs on the ALU. And this is to accommodate the slight change that I noticed in the selects for the ALU in this lab versus the original lab. Each of these is implemented in exactly the same fashion as the original lab. Each of the 4-bit bitwise operations is implemented at the gate level. The 4-to-1 mux is still used in mine, even though I know it wasn't a requirement, and this is simply for ease. I didn't want to modify anything that I didn't have to modify. And at the end of the day, there are some things that I would definitely change. The wiring is made a little more complicated by the ALU and how I've elected to do the circuit layout. I modified this to make it easier for me to see where things were going, and to make it more instantly apparent where they were. However, my choices on where to lay out the pins impacted the cleanliness of my final circuit. If I were to go back, I'd love to change that. As it is, we'll submit it as is, and I hope that this meets expectations. Thank you. It's been a great class.